Stephen Alonso here, and we just finished the final debate. It was over 3 hours, and it was pretty good. I was the second to present, which was great. What happened was he asked us one prepared question that he had, a difficult question, and then we had our own chance to make an argument for flat Earth. Why do we believe in flat Earth? And then the third section of the debate was where he picked two of the final experiments. There's 12 of them, and he got us to explain how they work on flat Earth. So it was a very structured, formalized event. It wasn't even about the shape of the Earth. There was these three formal structures. But the second part of the debate was very nice because I got to make a quick case about the sun's analemma, which is very important for us to understand because this is a sky observation that is objective, and we have to make it match the map or the world that we believe we live in. Now, for anyone who's not familiar, the sun's analemma is the photo of the sun in the sky at the same time, taken every day for a year. And you end up seeing a smaller loop in the north and a larger loop in the south. Well, that has to fit some model, and obviously we know that the North Polar AE projection has the larger south and the smaller north. So it fits right on that perfectly, and it helps us falsify other models, such as the South Polar AE. How do we know Antarctica isn't actually in the middle? And it's like a troll joke that goes within the flat Earth Globert groups, but there's a real reason for why the South Polar AE is falsified, and we know that we actually live on the North Polar AE, which is the Gleason. Now, talking about the sun's analemma, Will would not let us talk about the globe, because it makes the globe look silly in the arguments. But I still think it's important for everyone to understand how it works on the globe model. So the sun has a ground position, a latitude, and a longitude that is objective, not debatable. It's just easily measured that way. And we know that the sun goes between the tropics of Cancer and tropics of Capricorn. So with no tilt, notice how the globe's not tilted right now? So with a non-tilted globe, the sun would go up and down like this, making equal size top and bottom loops. But that's not what we observe. We observe a smaller loop in the top and a larger loop in the bottom. And you can see in that photo as well how it's on the actual map. When we put it on the Gleason map, it fits perfectly. And the only way to make that work on a globe is if you tilt it. So now as it's spinning, as the sun's going up and down, you can get a smaller loop and a larger south, but that's an additional step added to the globe model that's not required in the more realistic flat Earth. So the final debate was nice. I got to present that. The structure was all right, and it makes sense because if you see on my screen right here, there's 12 of the final experiment. So there's a lot, and we wanted to give everyone a fair time. So I was hoping we could discuss all 12. I planned to discuss all 12 as well. So that's why I'm going to do this video right now, just to make sure everyone knows about them. Because near the end of the final debate, there started to be some trolls. So I think there was only there's 4 genuine flat earthers who appeared, from what I remember. It was me, Ronnie and Jason from Awake Souls, so that's 3. Lindsay Harris, who has the Tomb of Illumination. So those were the 4 that I remember. And I'm just trying to think if I missed anyone. But yeah, not a lot of people showed up, and that's even why I made my previous video trying to make a call to action, because there's no real way not to show up. This stuff's easy to argue if you're a genuine flat earther. Now, my favorite part, though, was when I got to present my muscular weight that's been added over the last 6 months. So I got to mog all the globers and show off my muscular gains. You can even see Will's face too. Didn't expect that, and it's a nice smirk of proud that he can tell because he remembers me when I was 170 pounds, and I track my weight as well. So I weigh myself multiple times a week. So the weighted average is absolutely true. I know for a fact that I was 170 pounds. I know for another absolute fact that I'm 190 pounds now. And yet, weighing 20 pounds more, I look better than I did before. And that is crazy. Let me expand that out and move it over a bit. So you can see the trapezoids, the chest, the shoulders, the arms. So this is the Flat Earth Fitness program that I've been following consistently for 6 months now. If you go and check my live streams, you will see maybe around February or March, I was doing live workouts, and you can see the development over time, but also giving you like a kind of preview of what Flat Earth Fitness is. Flat Earth Fitness originally started as calisthenics, so at-home exercises on your floor. That's the flat Earth part, but it's very serious as well. You can do a lot. Like for the last 4 months, I've been doing the calisthenics. I have dumbbells as well and TRX straps, so it is a good home gym. But only the last 3 months, maybe 2.5, have I been at the gym 6 days of the week now. And that's what's really pushed my muscle development, but also allowed me to fine tune the gym plan so that it not only helps your muscles get bigger, but also helps your body become stronger. So when you're doing stuff like the squats, I was going to say powerlifting lifts, but there's only three that I actually do. It's the squats, the deadlifts, and the bench press. Those are the three that I have in my workout plan, but they're central nervous system exercises that really overload your body and work you out in a way that you just can't if you're at home doing calisthenics or whatever. So it's absolutely amazing, and it helps like your core stability. It's like athletic, functional bodybuilding so that your day-to-day life can absolutely be good. So that is StephenAlonso.fitness that you can go to and schedule a free consultation. We'll talk and see if we're going to be a good fit to work together. But I've been doing weight loss coaching for 5 years, but then to teach muscle building, I kind of have to actually do it myself. And part of my own fear being an ex-obese guy, I used to be 220 pounds at one point. So in my mind, it's a lot of kind of psychological getting over the idea that to actually gain weight and look better. But I'm doing it now, and that's my goal right now, to try to maximize the maximum amount of muscle that I can possibly do in a year. For people who just start strength training, and this is my first time strength training, I've never done progressive overloading where you start lifting heavier and heavier every time you're at the gym. The idea of benching 2 plates is something I couldn't even do when I just started at the gym. So 2 plate bench press is 135 pounds. But you'll see yourself, go to a gym right now, put 2 45-pound plates on the bench press. It's going to be dangerous. It's really hard to do. And I can now do that for 12 nice clean reps, because over time you do higher weights, more reps, and you progressively overload. So the gym is the real secret to do that. But 25 pounds of muscle is what a natural person, so someone not taking steroids, just trying to maximize the newbie gains for their first year, you can get 25 pounds of muscle. And for me, at the 6 month mark, we have to be very clear about these 20 pounds gained. Only about 12 pounds is actually muscle. We have to remember that another 5 pounds is creatine water retention, and then maybe 2 or 3 pounds of actual fat, because I'm in a calorie surplus. I'm eating more than I did before. But with creatine, creatine is one of the supplements that we have in our meal plans. But what it does, though, is it gives your muscles more ATP, adrenaline triphosphate. So it's actually all your cells, every single cell in the body. So your brain, your ability to think smarter, act quicker. It's a supplement you should have even if you're not working out. But for the purposes of exercise and endurance, our muscles also get extra ATP. So there's more energy. It's the difference between doing 10 reps and being able to do 11 reps. And those small differences really do add up, and you're in a committed plan like what I'm trying to teach you, doing 6 days a week for a proper exercise where there's 3 routines. You can scale it between 3 to 6 days a week, but 6 days a week means every muscle group is being worked out twice in a week. And we schedule it so that there's 48 to 72 hours to rest, but this is how to do it at the maximum optimal state. So to be able to mog in front of 1,000 people is quite nice. But what I want to talk about, though, are the 12 final experiments and how all of these work on flat Earth. And there's really nothing to be concerned or weird about at all. So I have it on my website. Anyone who wants to go over the article can. And there's 12 of them that Will made videos on. And For those of you who are just starting the video, I'm going to make a note that the real video starts around the 10-minute mark. If you don't want to listen to the intro, there'll be an intro and then the real video. From the 12 experiments, there's only 3, and 2 of them are partly the same. That would be what's called a yellow flag for academic research. It's something we have to look into to figure out how it works within our model, but it's not a red flag. It doesn't falsify anything. And those are the distance between meridians, and then the... Sorry, do we have it in quoted? What is 6 and 7? 6 and 7 are the South Pole flights and Southern Hemisphere flights. Those are both the same thing. So with that, those are the 2 things that we would have to still take into account. For me, I believe in the Lorentz ether theory, where the firmament has an etheric fluid in it. Ether is in our firmament, and that allows for compression when it's compressed more to the smaller end of the firmament, less compression in the north. And that is how we can end up having the distances around the North Pole measured the exact same as the distance around the entire firmament. So as ridiculous as that sounds, I'm being honest with you and telling at the moment, this is the best approach I have to it, but science is also still very young. So I'm just giving you guys theoretical models that work and allow us to have a starting framework that we can continue to develop, rather than being too scared to even approach and just trying to deny all 12. That's another reason too why only 4 flat earthers could show up. There's only a few of us who actually believe in the 24-hour sun. That's something really important to mention. All 4 of the flat earthers who showed up for the final debate, except the 24-hour sun in Antarctica, it's not a problem for us. And that is why becoming a senior flat earth researcher is so important now. You can't still be stuck at the junior level shaking your head trying to deny all this stuff because the original person who got you into flat earth tells you to be afraid of it and not to discuss it. Earth is measured flat, we need no model, end of story. You don't want to be that. I'm trying to take you from the junior level to the senior flat earth level, where when you approach these complex problems, you just start working them out. Okay, seeing how does this stuff work? So we can begin with the equatorial mount. It's very, very simple. These equatorial mounts are the azimuthal grids that we have around us. All it is a grid of arbitrary radius that represents an angle of elevation. For example, Polaris is 10 degrees from my horizon, and a compass azimuth. I'm just trying to see if I have my compass here or if I put it away, but I don't have it here. But it's those 2 things. So as you see here, I'm using a globe model to teach about these mini domes, because you'll see this on flat earth models in a 3rd-person view and it can confuse people. But there's other examples as well. So if you go into Stellarium and turn on the equatorial grid, that's what that right side is too, where you have a globe model with a 1st-person view of the equatorial grid. Now with flat earth models, they develop to a point where it's more advanced than globe models. You can go into a 3rd-person view and have multiple observers. And it's very important to remember that these aren't personalized domes. These are the exact same equatorial grid that the globe model uses. That's all. And the reason why we would argue that it is more of a proof of flat Earth is that when you try to project it onto a sphere, it doesn't work at all. So that is why there's very few third-person view globe models that even exist. There's one called the Dr. Marsh model, and that's what this photo is of here. And I'm just trying to see if I hyperlinked it. Yes, it's hyperlinked here. So if anyone wants to explore a 3D third-person view globe model that can give you a view Stellarium doesn't, explore it. Don't be afraid at all. This is the model that Jaren actually uses, but he doesn't realize how limited it is. For example, it's the sun only. It doesn't have the moon. It doesn't even have the planets like what the Firmament Tracker's Flat Earth model does. So Flat Earth software is the way the world actually is, and then when you start projecting it to a sphere, it starts to look silly like you see in this photo. But you can. It's important to understand that is a valid theoretical model. If you want to take Flat Earth, project it on a globe, you can make it work. But it's that additional step that's not required with the original starting point, the flat Earth, where this little thing comes from, which is that graticule. So, for example, I'm in Belize. If I go outside and look at Polaris, it's going to be 17 degrees from my horizon, and my latitude is also 17 degrees. That's all this is. So it starts with an observer-centric flat Earth, and if you choose to project it to anything you want, you can. But it looks stupid on a globe, and for me, it makes more sense to keep it flat. But that's all an equatorial grid is, and even like photographers or astronomers with a telescope, they can set it down, and it's just a flat Earth model. It'll point you to the sun, track it. It'll track it the exact same way any flat Earth model does. Now, with distance between meridians, that was the yellow flag one. Let me just confirm. Correct. So this is a yellow flag. The flat Earth does measure distances to be a globe. And that is something we have to approach with maturity, but also realize that it implies one of the two models is reverse engineered from each other. So if the globe model was going to be made, it would have to replicate what the real life flat Earth does. And either or. So having the globe measured to a flat Earth and the flat Earth measured to a globe, they have to be equal. So it's not a surprise, but it's important to, again, not try to deny it and make up measurements that don't exist. It's easier, in my opinion, to accept a hypothesis. Again, this isn't even my experiment. This is Will Duffy's, one of the 3 challenges, actually. So I'm doing a thought experiment, assuming what he's saying is true. Here is how it has to work. That doesn't mean this is how it actually works. It just means that assuming the premises I'm given, I'm going to be one of the only flat earthers to be able to submit the challenge in. And I was the only one, because to answer the challenge, I have to accept a conflicting idea. And it's important. You don't want to just deny reality or be afraid to even ask, what if? So number 3 is not an issue at all. This is what the flat Earth predicts. But if you're at the junior level still and you're denying gravity, you're gonna have a hard problem with this. Now, on a flat infinite plane, we use Gauss's law of gravity. The reason for this is because it's derived from Newton's law. So it's not debatable at all and has to be accepted by any glober approaching this discussion in good faith. Now, again, I'm not talking about arguing with the flat earther who denies gravity. There's a different way to talk to them. When you're dealing with the flat earther who denies gravity, you first start understanding how buoyancy works and how when you let go of balloons, you can measure with an accelerometer, and you can measure that, okay, there is a 9.8 meter per second acceleration coming from somewhere, and then you can predict that force. What is the downward force from gravity, assuming it exists? What is the upward force from buoyancy? And you get a net force, and you can compare the net force to just the buoyant force. So in the top right photo, that's the difference between 47 newtons and 51 newtons. Newtons is a measurement of force. Think of pushing something. There's a force that you exert. That's what we're measuring here. And you find out that the net force, which considers gravity, ends up being true. And you can deny this all you want, but study this screenshot, question it in the comments. I'll respond and teach you this. But this is how you go from the junior flat earther who denies gravity to a senior flat earther who accepts gravity. And at that point, when you approach a problem like weight variation at the poles, it's not a problem at all. We then think, okay, maybe we have to have an infinite plane of mass. Like maybe the universe is actually infinite. Earth, still being the Gleason map, is a finite area. We know latitude's not debated by globers or flat earthers. So we know the radius and finite area of the North Polar Gleason world, which rests on a flat infinite plane, which I would call the universe. And the reason we know that has to do with gravity. Now, the top model, I don't know if people believe in that, but if you do not believe we're on an infinite plane, you have to kind of think about what that implies. And it's kind of pointing to the floating disk in space model, which is kind of like a joke, but not a lot of people think about it. So the first time that you kind of realize that, okay, Earth has to be an infinite plane because the other alternative is it's finite, okay, then is there an edge? Like it comes to all the ridiculous stuff. No, there is no edge. But what happens is we know that if we drop something, it goes straight down. Where if Earth was finite, this is for people who believe in gravity. So you have to at least believe in gravity at this point. But what happens is, though, you would then know that it doesn't make sense. It has to be an infinite plane. Gravitational vectors point straight down. They don't point towards the North Pole, the center of mass. So on flat Earth, the symmetrical spread of an infinite quantity of mass results in perpendicular gravitational vectors. And this is Gauss's law. It's not debatable by anyone who accepts science. I'm a guy of science. I love science. Science is how we know the Earth is flat. Science is how we approach these problems as well. I'm not Gauss. I don't have to prove Gauss's law to reuse it. That's what's so great about how science is. We establish a law, and there is proof for Gauss's law. If you want to look up how to prove Gauss's law, you can do the mathematical proof yourself and realize that, okay, it is derived from Newton's law. And if I'm a glober who wants to approach this in good faith, I kind of have to accept this. And it helps support the idea that gravity doesn't work. Because you're globers who don't have the education level of a flat earther such as myself, and globers will misrepresent flat Earth saying gravity doesn't work, but it works perfectly fine. What we have to kind of consider, though, is that when we go higher up, there is a reduction in that force. So all that happens is the surface mass density has a gradient. So it would weigh more in the middle, weigh less above, and weigh lightest at the surface. That's it. And then the final thing is that we observe that there is a stronger force at the North Pole and the South Poles, but a weaker force at the equator. And how that has to happen then is that means there's a lateral surface mass density. So it changes going across. What that means is at the equator, it would weigh less than it does weigh at the North Poles and the South Pole. And that is just simply how the world would have to be designed. But it's important to understand, though, that all that really matters is the proportionality that I'm discussing. The actual gradient surface mass density doesn't need to be measured because we're only trying to show a proof of concept. We're trying to show a theoretical model of how this starts, and then we can then develop these scaling laws into measurable constants and go on. But this is the starting point for the third final experiment. It's not a problem at all. And this is a realistic depiction of what our universe looks like. And for all we know, there could be other domes, there could be land beyond the poles. That's fine. That all works on an infinite plane. All I'm telling you is that based on the way science works and our observable reality works, we 100% live on an infinite plane. The idea of a floating disk in space had just been falsified. Crossing Antarctica isn't really an issue for me. There's the realistic explanation where the relative distance going around the firmament is the same as going around the North Pole. That is how I approach it with the Lorentz ether length transformations. And again, this is assuming that what these people are saying is true. We don't actually know if anyone's actually done that. And how it would have to work then on flat Earth, you know how on your compass, perfectly south would be 180 degrees? Realistically, what's happening is they're going 179 or 181 and going off and just wrapping around. At the moment, this is how I understand it to work. I don't think there's any teleportation, virtual reality. I would rather look at a real physical concept that does exist, that special relativity uses for all its experimental predictions. That is what the Lorentz ether transform has done through special relativity. So again, it's something that Glober can't deny. They can argue the application of what I'm doing, and that's a perfectly valid debate, but they can't deny the law itself. And it's a theoretical model that works fine for now. And again, based on the assumption they did what they claim. Now, shadow predictions are nothing special either. You would first have to learn about the equatorial grid, understand that it's pointing towards either the north or the south celestial pole. And what I mean by that is, for those of us in the north, we would be pointing it towards Polaris. And then the sun just goes right over that. It's a very simple concept that's not too confusing at all. I made my own flat Earth sundial. Again, watch the link in the description, watch this video. You can get a compass and a stick, and make a flatter sundial in your backyard. And it's a really cool way to learn about the equatorial grid, because you'll find out that like at 12 o'clock, it'll be directly over your stick, and you can kind of visualize that in the other images we showed before. But just like in a flat Earth model, during the final experiment, we had MC Toon make one of the predictions that then validated the flat Earth model. So we show a sundial, and we know it has to be pointed at the latitude of the observer. So if you're at 80 degrees of south latitude, you would point your sundial 80 degrees up, which is the south celestial pole. So even if you can't see the south celestial pole, it still exists and it's there. It's equal to your latitude. And this is very easily proven with Polaris, and you can triangulate the stars with the Southern Cross to find the south celestial pole. But this is not a problem for flat Earth. The sun rotates around that stick in the flat Earth model, and it's what we see in real life when you just get a simple stick and test it in your backyard. So 6 and 7 are the yellow flags that I talked about. We either have to accept that there's a Lorentz transformation, deny the flights at all. But again, I don't think we need to deny the flights. You're more than welcome to. And even if you want to, that's not even the purpose of Will Duffy's final experiments. For 6 and 7, it's assuming this is true. How is it going to work? And this is how it would work. The South Pole itself is a good one. And you want to start by clarifying the differences between the magnetic South Pole, the geographic South Pole, the geographic poles, and the celestial poles, because there's 3 types. So when we talk about a magnetic pole, let me see if I have that. That would be slide 8. The magnetic pole, there's a north pole and an infinite amount of south poles. That's how a radial field works. It should be nothing complicated at all. Now, when we talk about a geographic pole, that does not exist on a flat Earth model, the North Polar AE, because longitude is a continuous coordinate system. There can be not a single spot where a latitude of -90 holds. So on flat Earth, we have to make a choice. You can choose where you want to place this. And based off of the research I've done, I found that the geographic pole would be southeast of New Zealand, which would be southwest of the US, shown right here. So the geographic South Pole is the Amundsen Scott South Pole Station. That's where they would go to get there. And that's not really nothing to be confused about at all. The other thing would then be the celestial poles, and we discussed that in section 10. So I will just skip that for now and go back to section 9, sunrise and sunset direction. This was TFE challenge number 2. Again, as one of the only senior flat Earth researchers left these days, I was the only one to submit a prediction for this. But again, it's very simple stuff. We use that equatorial grid. Every observer has their own equatorial grid around them that we use for math predictions. It's a right angle with an elevation to the object and then a compass direction. And to clarify something, the celestial sphere is a globe-based concept. And there's only one celestial sphere that can exist at a time, where you can have multiple equatorial grids. An equatorial grid is an observer-centric tool. It's the arbitrary grid around an observer, not the center of the Earth. A celestial sphere is centered on the middle of the globe, the core, and it can't really apply to flat Earth at all. But on a globe model, as I shown, you can still have a celestial sphere with multiple equatorial grids. So on this globe, there would still be a celestial sphere outside of an arbitrary radius among with those 2 equatorial grids. So understand the difference. Every observer has an equatorial grid. However, there's only ever one celestial sphere. The celestial sphere is centered on the middle of the globe and is an inherently a globe-based concept, where the equatorial grid, there's multiple of them and has to do with the observer itself, and it has nothing to do with the projection you choose to put it out on. An equatorial grid can exist on a globe, but it can also exist on the Awake Souls SBVR oblique Mercator model. It can exist on the North Polar AE. It could exist on the South Polar AE. You have all those options. So that is very important to understand. And then going back to number 9, when we go to the sunsets and sunrise directions, looking at this image, it should make perfect sense to you. The image on the left is when the sun would be rising and then it arcs over and comes down. And the reason we have those lines, again, it's not made up. The sun travels among that path. So those lines that wrap around, that is literally the observer's orbit of this object. So these aren't just made up for a reason. This is really what we see every day. And it's, again, based on that concept of the graticule. So understand the graticule, where you go outside and look at Polaris, note down that angle, and note your latitude. That is the graticule, and it's entirely separate from the projections that you can choose to go out with. So again, this is on the website. Click here, read through this whole PDF about how this stuff works. Understand how the flat Earth model works. That's why I do this for you guys. Now, number 10 is the South Celestial Pole. Again, it's a very simple concept to understand because we have the declination and right ascension, and we have longitude being a continuous coordinate system. So let me just see what slides I brought here. I could share this. So this is one of the links there. If you go over there, you can click on this link. But it explains how we have an infinite amount of south celestial poles. Someone in Chile and New Zealand are both looking south, and what happens is they both end up seeing the Southern Cross, but it's rotated depending on what direction of the firmament you're looking at. So notice here, the observer is looking at 2 different parts of the firmament, and see how far spread the observers are apart. This is that dome refraction giving the observers 2 different views. It's not the same view. Now, if these were the exact same, that would be a huge problem, but it's not. We know that it's rotated, and it's rotated depending on how far the observer is away from each other. This makes sense on a flat Earth with an infinite amount of south celestial poles from a dome refraction. Now, remember, there's only one Southern Cross in this case. So this star here, there's only one, and it's on the top of the firmament, shining through. So let me clarify how this works. We're talking about dome refraction, how one object shines through the firmament and goes out to the observers. You need to understand this, otherwise it's going to be very confusing when we get into the senior level topics, such as the South Celestial Pole. Yeah, the 24-hour moon is nothing special at all. It's the exact same as a 24-hour Polaris. The math is nothing special at all. You find the celestial declination for it, which I believe has a range of 28 to negative 28, which means it is absolutely possible for it to happen in Union Glacier. Just like how with the 24-hour sun, it had a celestial declination of negative 23. So with the celestial declination of negative 23, we can do the flat Earth math and figure out that, okay, there is definitely going to be a 24-hour sun, and it's not that confusing at all. So let's go to, I think, experiment right here. There's a 24-hour visibility formula that uses a right angle, because we're talking about flat Earth, not a globe, and you take in the observer's latitude, the celestial declination. So that negative 23 that you're seeing here, this is from where the sun is physically on the firmament above us. And that's extremely important to understand. Declination refers to a sky coordinate. It just so happens to also equal the latitude because the Earth is flat, but that just makes the math so much easier. But, for example, when the sun has a sky coordinate, a celestial declination of negative 23, that means it's going to be over the Tropic of Capricorn at negative 23 degrees south latitude. It's very, very simple. So it's super easy to do, and that is how we can make a prediction that, yeah, an observer at Union Glacier is absolutely going to see a 24-hour sun in December. It's a binary, either true or false. It wasn't a maybe. It's the flat Earth model absolutely predicts this, and that's what makes sense. There's just no other way to do it Otherwise, you have no model. So you can check my other videos to figure out the issue when you start denying basic flat Earth math. Let me see what else we have to talk about. We talked about the 24-hour moon. We went over that. Yeah, actually, I strongly encourage you guys to make a sundial in your backyard. Break a stick off a tree, get a compass out, point it towards Polaris based on the angle of elevation of your latitude. So if your latitude is 45 degrees north in the United States, Canada, point your stick 45 degrees up. It's really cool, and it's a great way to start learning about how our flat Earth works, understand why predictions like this make 100%, and any flat earther with common sense should be able to approach it, or at least take the time to work through it or understand how it works. And again, I may be speaking from a point of privilege, having the ability to code these flat earth models myself. So again, when I'm presented with this problem, I start thinking through the same code that I use to make the exact image you're seeing. This is from my model, the Firmament Trackers Flat Earth app that you can download for free on the Apple or Android App Store. But in my mind, I start walking through that process, and I don't know if it's just logically, mechanically, intuitively, this makes 100% sense to me. And I guess because of that point of privilege is kind of why I had the obligation 6 months ago to start responding to all of these TFE challenges. If I'm the only flat earther who can really address this, then fuck, I gotta do it. It's not really something I can choose to not do, because people need to understand how the universe itself works. And there's a new generation who will be coming into flat earth, and they want someone who's mature, educated, that they can actually look up to, not just for that, but also for life itself. How do you become a real man that becomes a better person, that holds respect when you walk in the room? And that's why flat earth fitness is so important, because you need to become like, you can just see people's faces when they see it. It's just something impressive, because it does take work, commitment, but overall it makes your mind sharp. You're quicker, you're more confident as a person. So I believe we covered all the 12 of the final experiments. That was a nice 35-minute talk with you. Remember, the first 10 minutes, though, were more of an introduction. So realistically, this can be considered a 25-minute video where we got to discuss this all. And feel free to check out the website so you can view that same article we were scrolling through, the links, try to learn about stuff. My comments are always open. If you have a question, I probably will answer it or post the link where you can find out the information. At the end of the day, all this just helps us get a more coherent flat earth model. I don't understand why these topics are scary to look at. To me, I love science. It's cool to learn more about how our world works, and then understand how it actually works on flat earth, and learn about how it would work on the globe as well, and see which one makes the most sense to us. And I've always found that the Gleason map seems to be the most cohesive, most coherent. Everything, the sun's in a lemma, I've never found a valid reason to have to use a globe model to try to explain something. And I hope by making this video we can also start working out number 2 and number 6 and 7. How do we approach the distance between meridians in the South Pole flights? Am I right that there is actually a length contraction if we were to travel through the ether? Perhaps I should talk to Alan and Shane from Space Audits. They may know more about that. I might be able to give a better answer on that. But that's where we should continue progressing science. It's not about saying, I don't know, therefore I'm going to give up and the Earth is a globe. It just never makes sense for me. When you become a senior flat Earth researcher, the mind frame that you need to start having is, okay, how does this work on a flat Earth? And we attempt to falsify it. And if we falsify a flat Earth, cool. We should always be willing to learn that the Earth isn't flat. But based on a lot of hours, several years of research, I have over 5 years of experience, I've never actually been afraid to approach that, because I honestly don't think I'll ever find any new information that can like debunk the 5 years that I've already studied. So for me, I'm just going to look at the information and have an open mind. Would it suck if I found out the Earth is a globe? No. I'm open to it, because even if the Earth is a globe, that still means Earth could be the geocentric globe. It doesn't have to be the heliocentric model. So there's still so much more to explore. Earth could still be the center of our universe, which is one of the things we know is true based on how higher levels of science works. Earth does hold a special frame of reference in the entire universe. That's one of the reasons we also look towards the flat Earth model, because we know no matter what, we are the center of the Earth and everything revolves around us. But that could also work on the globe as well. But then you're still introduced to all the previous problems I discussed. But all I'm trying to say is don't be afraid of learning how the globe works. I find that the more I study it, the more ridiculous it looks, and I've never found a reason to go to it more than just how beautiful the flat Earth model is, how everything works. We look up in a sky, see the sun's in a lemma, it fits right on the Gleason map, or how when we start trying to go to a globe, we have to start putting flat Earth on the globe, which was that Dr. Marsh model I was showing earlier. Let me see if I have that over here again. So you still have all the problems when you choose a globe that, in my opinion, Flat Earth is at a really good place right now, and I look forward to continue making videos. So this would be kind of the ending of the final experiment, also the ending of the Glyphs on Ice book that I've been covering for the last since December of 2024. I've been covering the final experiment, so I'm going to wrap that book out, make sure it's going to be available for all you guys who ordered. The pre-order was only $25, so very cheap. You guys are still going to get that. I think the actual price might be $35 when it comes out. We'll see. And that's including the free shipping. So yeah, that's all going to be wonderful. And the Glyphs on Ice book will cover this, plus a bunch of other stuff as well. So, for example, I'm just trying to think, Lisbeth, she took down all her LinkedIn stuff. She's gone hidden, trying to hide. So that's the whole mystery that I have all the past on. That's going to be in the book. There's a ton of other kind of cool stuff that we're going to look into. I tried to push the boundaries as far as I legally could. And I believe it's okay. Everyone who chose to participate in the final experiment gave their permission to have this public information. It is all public stuff, so don't get me wrong, everything's public. But I've been covering it since December, so I have a really big catalog and quite a good history of all the stuff, so I'm looking forward to that. The Glyphs on Ice book, I don't know if you guys have the link for that, but I may put that in the comments, promote the old website again, see that going for a bit. But yeah, you guys all have a wonderful day. This was a good video to cover, and making sure that everyone knows that there's nothing at all to worry about. All the final experiments make sense.